Okay, this is a video of me going through the problems on 1.3c, domain and range. All right, so let's start with A. So the domain, the only thing that is problematic here is the square root. So we need to make sure that we're only taking a square root of positive values. So we need x minus 3 to the fourth plus 8 to be greater than or equal to 0. Or x minus 3 to the fourth to be greater than or equal to negative 8, which is always the case because something to an even power is always going to be 0 or a positive, which means I can put anything in for x here. So the domain is all reals, no restriction there. Okay, so for the range, I'm going to leave a little space here and below do some analysis. So I've got my negative 3, and then under the square root, I know something to the fourth power is going to be smallest is 0 to infinity. Then I have the plus 8, and then my plus 4 outside. So now just doing my order of operations, I've got negative 3. Inside will range from 8 to infinity, then plus 4. Okay, so taking out of the square root 8 and infinity, I'm going to get negative 3 times the square root of 8 is, well, square root of 8 can be simplified to 2 root 2. So I'm going to have negative 6 root 2. And then negative 3 times infinity is actually going to be negative infinity. So negative times a hugely positive number is going to go towards a hugely negative number. And then I've got plus 4. So my range here is negative infinity, negative 6 root 2 plus 4 inclusive. Okay, b of x. All right, so start off the same way. I've got a square root, and I need what's inside the square root to be greater than or equal to 0. So I need 81 has to be greater than or equal to x plus 5 to the fourth. Or in other words, I need x plus 5. The fourth root of 81 is 3. So in order for 81 minus x plus 5 to the fourth to be 0 or positive, I need x plus 5 to be between negative 3 and 3, which means I need x to be between negative 8 and negative 2. So that will be my domain. So domain is negative 8 to negative 2. And now for the range. Let's do, maybe I'll do my analysis to the left here. I'm going to do it in a different color so it doesn't get blended in with everything else. So I've got 2. This is for the range of b of x. 2 times, well, 81, actually, I'll just do it out. So 81 minus 0, and remember the biggest it can be so that I don't have a negative inside the square root, is 0 to 81. And then I've got the minus 9. So 81 minus 0 is 81. 81 minus 81 is 0. So inside the square root, we're going to range from 0 to 81. And then I've got minus 9. So that means coming out of the square root, I've got 2 times 0 to 9 minus 9, or I've got 2 times 0 is 0, 2 times 9 is 18 minus 9, and subtracting 9 from each piece, I've got the range going from negative 9 to 9, inclusive. Remember, you can do the square root of 0, and it's 0. All right, let's scroll down a little bit here. All right, for C. All right, so there's no square root. I do have a variable in the denominator. So for the domain, I need to make sure that the denominator can equal 0. So I need to make sure that x plus 2 squared can't equal negative 7, and it never can. You can't have something squared equaling a negative. So it means I can put anything in for x. Now for the range. So doing the analysis here, I do have some limitations in the denominator because x plus 2 squared, the smallest it can be is 0, and then it will go towards infinity, plus 7, and I've got the minus 5. So this means that I have 8 divided by 7 to infinity, and then I have this minus 5 here. Well, remember what we always want to check when we have something like this, a fraction with the denominator ranging. We want to check our extremes to see if it hits all of these. And I know it's never going to equal 0 because the only way a fraction equals 0 is if the numerator is 0, which it can't be in this case. And so just looking at this piece, I've circled this fractional piece. Because it's all positives here, I know I'm not going to have the negatives in play. So the question is, can it get super close to 0 from the positive side? And it can, because 8 over something hugely positive gets very close to 0. So I'm going to get, and again, I'm just doing the fractional piece right now. The negative 5, I'm just going to leave for a second. So 8 over something hugely positive is going to get super close to 0 from that positive side. But I'm never going to explode towards positive infinity, because in order to do that, I would have to have 8 over a tiny positive. And the smallest positive value I have in the denominator is 7. So that means that the biggest it's going to get is going to be 8 sevenths. And of course, I have this minus 5. So my range is going to be minus 5, and I've got minus 5 plus 8 sevenths, which is going to be negative 5. And combining negative 5 plus 8 sevenths gives me negative 27 sevenths, inclusive. So that was a little bit more challenging. All right, so again, the more you can go piece by piece with the range, the easier and the more likely you are to get the correct answer versus looking something over and kind of hoping that it's the easier path. So, all right, so because the mistake people make on C of X is just saying, oh, okay, that fractional piece can be anything but 0, and then I just subtract 5. So just be careful about that. All right, so for d of x, let's do the domain first. So x minus 1 cubed minus 27 cannot equal 0, or x minus 1 cubed cannot equal 27. Remember, when you do an odd root of something and take the odd root of both sides, it's not plus or minus. It's not like an even root. It's just the cube root of something is only one answer. So the cube root of 27 is just 3. So x cannot be 4. So my domain is negative infinity to 4, union 4 to infinity. Okay, so now when I think about doing my range analysis, let me do a different color here. 8 divided by, well, something to the third power can be anything. And it can be positive and negative. So the only thing in the denominator I can't have, including when I add the negative 27 to the mix, is I just can't divide by 0. But otherwise, it can take on any value here. Then I've got plus 2. So because of that, the only thing this fractional piece can't be, because I've got that 8 in the numerator, is it can't be 0. So I've got the range being negative infinity to 0, 0 to infinity, and then the plus 2. So that means this whole function can be anything but 2. Okay. Now let's look at e of x, which in some ways is definitely a simpler problem than the ones we just did, C and D. All right, so the only issue is the denominator. I can't have x minus 5 be 0, so the domain means it can be anything but 5. And the denominator here can take on any value but 0. So like the previous problem, this fractional piece can take on anything but 0, because the only way a fraction can be 0 is if the numerator is 0. So adding 14 to that means the range can be anything but 14. Okay, last problem. Right away, you should recognize that, oh, I have the x in the numerator and the x in the denominator to the first degree. So I think of this as the k problem, which is going to come into play when we do our range. But the domain here is straightforward, just can't be 1. That's where the denominator is 0. In terms of the range, we think about, okay, since I have x, again, linear in the numerator and denominator, I'm setting it equal to some random k to figure out what is an output that I can't have in this case. And the only way I can't solve this linear equation is if k is 3, because then the x's would cancel, parallel lines don't intersect, and so on. So k cannot be 3, so my range is everything but 3. And that is it.